Okay, so for today, I had the kids start with a circle trig problem. Cosine of 10 pi over 6. And I know that's kind of weird because normally people reduce those. But I like you to know where the pi over 6's are. And because they're my favorite ones because I think they come up the most. So this is where 1 pi over 6 would be. 2, 3, and then after you keep going like that, you start getting used to where they go. And if you by accident go like 4, 5, you'll be like, wait a minute, 5 pi over 6 is there? That doesn't make sense. Oh, I screwed this one up. See, it'll help you realize how big the wedges are. 4, 5, 6 pi over 6. Okay, I'm getting there. 7, 8, 9 pi over 6, and this one here must have been the 10 pi over 6. I'll make it red to make it special. Raise your hand if you put that in the right spot. Okay, cool. Now, I had a kid come up and ask me, she said, I thought that this one was going to be 30. And here's why that one is not 30. It's because each of these wedges we just did were 30. That means this was 30. That means this must be 60 in there. How many of you knew that that was a 60? Okay, awesome. And then this is the right part of the triangle, and then this must be 30. And then whenever I write the 30, I immediately go across from it and put the 1 over there. Because that's the next common mistake, is to put the 1 in the wrong spot. That's where the 1 goes. The 1 is right across from the 30-degree angle. And then the 2 is over here, and the square root of 3 is here. Who remembered to make it negative square root of 3? Nice. Only like a third of you made that oops, and it is very common to forget the negative. And then if I was gonna do cosine, I gotta know which angle to do it from. Like cosine from the 30 would be totally different than cosine from the 60. That one is the RA. What does that stand for? The what? Remember? Yes, the reference angle. Very good. It's also known as the central angle. Same word, or I mean, it means the same thing in this context. Okay, so the reference angle is the one we're going to use when we actually do cosine. So what is cosine? Once again, I have to refer to a little thing. SOHCAHTOA. You see how many little things you have to know? You have to know the 30, 60, 90 triangle. You have to know how to tell which side is 1, 2, and square root of 3. You have to know what cosine means. That. You have to know what adjacent means. Adjacent means right next to. Which one's next door? Well, that one's next door, but that's the hypotenuse. That one's next door. 1 over the hypotenuse, which is 2. They're both positive, so it looks like it's just positive 1/2, and it is. Raise your hand if you had positive 1/2. Sweet. So we're ahead, which is awesome. That only means we can focus on some of the like trickier things, because you're already doing, that is like one of the R3 questions on your test. And one of your R2 questions built in. Because the R2 level question would just be to make me the reference triangle. An R3 level question would be to actually go and find the cosine of that triangle. All right. And other things you had to know along the way, like the fact that this is negative, that could, be something that we'd have in an R2. Just so many little facts you got to know for this test. Okay, I want to actually look at the beginning of the notes because it's a review of yesterday's stuff, and I want to look at number 10 because just looking at that, a lot of times your eyes cross and you're like, what do they even want? I don't understand. So let's look at number 10. I know you probably did it on last night's homework, but just with fresh eyes, right away, you should go, I'm not going to do secant. I peacefully refuse to do secant. Because there's a sister function to that. Do you remember those sister functions? I'm going to go off to the side and write these for you. Sine, cosine, and tangent are the key big three. And then I'm going to put an arrow right here because it's not equal to the sister function, but it goes with it. I'm not saying equals. I'm saying arrow to cosecant, CSC. Would you please finish these two? Do that right now. It'll help connect the 6 functions all together in your head. That's for sure something that's on this test. We just taught you 3 new trig functions called cosecant, secant, and cotangent. If you don't know them, you're going to get things wrong in this test. Okay, so I gave you this tip. S goes with C, and C goes with S. So at least you know to start with an S. And it's SEC, secant. And the last one is cotangent. Okay, now, if you've written this like I asked you to, please erase this and this and this, and we're going to make some actual numbers here. I'm going to give you a triangle above it, and we're going to do this one that they gave us. Secant of theta is 7 over 3. Okay, then I don't know what the triangle looks like, so don't do it that way. I know this seems like small stuff, but I've been doing this a long time, and I know a lot of tricks that really help. Draw your triangle short and fat every time. Because if you draw it long and skinny, and then you realize that this side's supposed to be 7 and this side's supposed to be 3, you're going to be like, what? This isn't right. So draw it short and fat. If you don't know what it looks like, make your triangle kind of like a 45, 45, 90. Mr. Bontius, was that a cell phone? Okay, good. All right, so, glad it wasn't. This is short and fat so that, just like Mr. Server said, that way if I said this was 30, you could probably believe it. You know what I mean? It's like not that far off of 30. And if I said this side was 7, you could be like, okay, fine. But if you draw them long, skinny triangles, you'll end up with weird situations that don't make sense in your head. So trust me, whenever you draw a random triangle, make it short and fat. Because your eyes can be like, it'll work better, trust me. Okay, secant is 7/3. I'm not going to do secant is 7/3. I'm going to refuse to do secant is 7/3, but instead I'm going to do, what goes with secant again? Look down on the chart. Cosine. I'm going to do cosine of theta is 3/7. And then you get to pick what angle you want. I'm going to choose this to be my angle that I like to go from. I don't like to have it on the top. It feels more logical to me to have it kind of on the side. You get to pick that. And now cosine is ka, adjacent and hypotenuse. So they just told me 2 of the sides of the triangle. The adjacent side is 3 and the hypotenuse is 7. And could you believe that? Like, is it looking really weird to your eyes? No, that seems like believable to me. You know, when the one's shorter and the one's longer, and so trust me, make it short and fat, and then your eyes you won't get all confused by a mislabeled triangle. Now, do you remember how to find that third side? What do you start with over here? You always start with something. Square root. And then you square them both, and then you got to figure out whether you add them or subtract them. If you're on the longest side, you'll add them. So this would be 49 and 9. And am I on the longest side? No, then I subtract them. So then I guess it's square root of 40. So many little things you have to know in math. You also have to know how to simplify that. Take a second, make it 2 square roots, and simplify it down to like 3 root 5 or something. Take a second, simplify it down. In a moment, I'm going to ask you to see if you and your partner got the same thing for that. It is not 3 root 5, but it simplifies to 2 square roots, which then simplify further. See what you think it simplifies to. Kind of like 3 root 5, but not that. Okay, usually most kids have got this skill because it's one of those that was on the top 20, or the first 20. I'm sorry, most of you guys just did the first 20 in first semester. But some of you guys were like, that first 20 stuff doesn't matter. You know, that's not really the real math we're doing. Yes, it is. This right here is one of the skills that's on there. And if you would have taken the time to learn the first 20, this would have been easy for you. Root 4 and root 10, which is 2 root 10. It's those little moments like that often cause people to get their math problems wrong because it's a little old thing that they forgot. That's why you got to know those things. Because here in the middle of a really hard question, if you don't know how to simplify these, you're losing points. All right, so now it's down to just 2 root 10. All of that work and we just got it set up. Does that make sense to you so far? All right, so then would you please figure out what these 6 answers are? Sine of it, and then as soon as I know sine of it, I'm going to go over here and flip it. Find those 6 answers. I'll pause for a second and give that a shot. Okay, so sine of this angle. Sine is opposite over hypotenuse. This one's the opposite side from here, right? Opposite, 2 root 10 over hypotenuse of 7. Who had 2 root 10 over 7? Okay, good. And then I just have to flip it. 7 over 2 root 10. And then down to cosine. Cosine is adjacent over hypotenuse, 3 over 7. And then just flip it, 7 over 3. And then tangent, TOA, opposite. This one's the opposite side. 2 root 10 over nope, tangent is TOA, opposite over adjacent, 3. And then I flip it, 3 over 2 root 10. That is some hardcore math. Like, it is really tricky math. All right, but that's all review. Nothing really was new there. So now let's get into new slides for today. So arrow down to here. Evaluate trig expressions involving pi over 3, pi over 6, and pi over 4. We have done that for 3 days now. I introduced that 3 days ago. Because today's lesson would have been so hard if I hadn't. So by now, you're already pretty good at the main thing for today. Because there's so many little pieces that I need to explain even still. So we got some work done ahead of time so that at this moment, we could look at this stuff and you'd be like, yeah, I already know those. 1 root 2, right? You got those down, don't you? All right. And this one, 1, 2, and root 3. And then what's different about these? They just have, instead of 30, they have pi over 6. And again, I hope you already know that one. And I hope that 60 goes with pi over 3 in your head. If you're ever like, I don't remember which one this is, then put 180 here. And in your head, you got to be able to divide quick and go 18 divided by 3 is 6. Oh, this is the 60 one. You know what I mean? You can change these in your head with that quick little swap of 180 is pi. All right, so these are just identical to each other. So what I want to talk about then, since we've already talked about this, is I want to say, do you think every triangle in the world has a length of 1? Of course not. What if it has a length of 5 here? Then you think of it as 5 times bigger than normal, and then what will this other side have to be? 5. And what will the other side have to be? No, close. You multiply it under the root. Can't do that. You multiply outside the root, 5 root 2. You get the difference there? It's not root 10. It's 5 times it. See, we times them all by 5. Do you get if I want to times them all by 5, I can? I can make it 5 times bigger. But I can't like times these two by 5 and not times that one by 5. I mean, that wouldn't keep it the same. Okay, so if you're going to keep it at 45, 45, 90, you got to multiply them all by 5 if you want to. Okay, so that brings up an important point. Like, why would you ever do that? Well, because not all triangles have a length of 1. There are plenty of 45, 45, 90 triangles out there. Look at a bookshelf. Or look at what holds a shelf up on the wall. Like, let's say I have a shelf here. Here's my wall. And then here's a shelf that I'm going to, like, put a little figurine on, like a little snowman in the wintertime or whatever. And guess what holds it up? A little bracket, which is a 45, 45, 90 triangle. Do you think it's exactly 1 inch by 1 inch? No, it's going to be like, I don't know, 4 inches by 4 inches. So then you can go, well, I guess I times the ones. Those would have been ones. I times it by 4, so this is 4 root 2. See how I could do that in my head quick? Because I knew that a normal triangle would have been 1, 1, and square root of 2. I can just scale them up, times them all by 4. All right, so let me show you something else about why we sometimes don't want our radius to be weird, like 1, 1, and the square root of 2. Would you please draw that triangle for me? This is the most common one. It is the most important one. Because it's the simple one. 1, 1, and root 2. You gotta know those ratios. So it's a 45, 45, 90, so everybody put a little block right there that shows that's a 90-degree angle. And I just said a second ago, you can times this by anything you want. You could make this like times 8, times 8. Don't do it, but you could, as long as you times everything by 8. But here's the thing you often want to times it by. You often want to make the circle, remember me saying we'd like make a million of these where there's like a circle and the X and Y axis goes through it and stuff? They often want the radius to be 1 for what's called a unit circle. Have you ever heard of a unit circle? It's a big deal, and it's coming, and I'm trying to get you ready for it. The unit circle, unit means 1, has a radius of 1. Does mine have a radius of 1? Right now, does mine have a radius of 1? No, the radius is this thing, and it's not 1. But if I want to, I could divide it by the square root of 2, and that would make it into 1, wouldn't it? Do you get what I just did there? I made my right triangle stay the same proportions, but instead of multiplying everything by something, I divided everything by something, because root 2 over root 2 is now equal to 1. Do you get that? Now I have a weirder looking, but still 45, 45, 90 triangle where that's 1, and this is 1 over root 2, and this is 1 over root 2. You can understand why we wouldn't have you memorize it that way, because it's so confusing looking. But would you agree that these two sides are still the same, right? And they're all in proportion to what they used to be. It's still 45, 45, 90. But the radius is 1 now. All right. Last little piece that I need you to understand is it's not you're going to always like divide by the square root of 2. What if our radius of our circle had been 8? What if this was an 8? Do you get, I might say, you know what? I want the radius to be 1. What would you have to do to all your sides? To get this 8 to be a 1, what would you have to do? Divide it by 8. You'd have to divide everything by 8. Do you get the idea? You can make this radius be 1 by doing something to it as long as you do it to all 3 parts. Okay, and the other thing we got to talk over, which again would have made this day impossible if I hadn't like pre-taught you this stuff, is rationalizing. I showed you this the other day. Why would you ever want to do that? Well, that's equal to 1, so it's legal to do, but why would I want to do it? It's because the denominator, when you're dividing by something, you shouldn't be dividing by a decimal that goes on forever and never repeats. So this is really now the square root of 4, which is really 2. And the top, this is a times problem, is the square root of 2. You don't know yet why this is a big deal. But on the unit circle, the big circle that has got all the trig on it, you see root 2 over 2 on it. All over the place. It's literally there. 1, 2, 3, 4, 5. At least 7 times on that circle you see root 2 over 2. And I'm trying to show you why you see that all over the place. It's because this 1 over root 2, which made us have a unit 1 radius, the radius became 1, and all of a sudden now this needs to be cleaned up because you can't divide by a square root, so all of a sudden it's root 2 over 2. That's why there's root 2 over 2 all over the place. Do you get that this becomes root 4, which is 2, and that's root 2. So this side is root 2 over 2, this side is root 2 over 2, and this side is 1. All right, let's make sure you get rationalizing. What if I had 1 over root 3? Rationalize that. Make it so you're not dividing by the weird decimal. Do you know how to rationalize yet? This does come up on the ACT. Pretty much once, one problem out of your 60 will have something to do with this. I'm not promising it. I'm just saying usually. This is somewhere on the ACT that they rationalized. Did you multiply by root 3 over root 3? All right, good. And then that became root 9, which is really 3. And the top would be root 3. Does that make sense to you? Okay, cool. I want to give you one more that just looks really weird. 2 over root 2. Everybody write that one. Rationalize it. Do that thing that makes it so you're not dividing by a weird decimal. And you're going to be like, what? What's the square root of 2 times the square root of 2? It's the square root of 4. What's the square root of 4? It's 2. And what's on top? 2 root 2. And then the 2's canceled. So it's just root 2. Wait a minute. So server, you're telling me that 2 over root 2 actually is the same exact thing as root 2? Yep. They're equal. They're the same thing. It makes my head hurt, but it's true. Oh, wait a minute. Yes. Even now my head is freaking out. Yes, this is the same thing. They're equal. All right, and why is this better? Because it's not dividing by a decimal that never ends and never repeats. Okay. So, moral of the story is you have to be able to handle when I want the radius, which is always the hypotenuse, when I want that radius to be like, here, let's say I had this. And I'm like, but this needs to be 1. You got to be able to go, okay, so I want to divide by the square root of 8. And then this is 1 now. And that's what you wanted. Okay, cool. But then you got this problem. You're not supposed to divide by a square root. So then you have to know how to fix it with this. And this becomes root 8 over root 64, which is 8. And then you have to know how to simplify that. Oh my gosh. That's got so many little pieces. So thankfully I had time to talk about that. I know you're not all experts in it, but you've seen rationalizing now. And you've seen that sometimes we want the radius to be 1. And those are really important for later. All right, moving on to this page. In trig functions, would you agree that in any function you have an input and you have an output? So what is what? Let me show you something you will never do. Sine is 1/2. That doesn't make any sense. It doesn't have any input. What's missing here? The angle. You'd have to have like an angle here or it doesn't make any sense. There is no such thing as just sine or just cosine. Cosine of an angle can be something. Just sine doesn't exist. It only makes sense if it has an input. That's the input, and that's the output. That makes sense? You'll never write this. Cosine is 2/3. Never, ever, ever, because it doesn't have an angle. Wouldn't make any sense. It just doesn't make any sense. Could you say cosine of, well, I don't know what the angle is. Put a theta there. You need something there. You need a spot to put the input. So if you don't know what the angle is, put a theta. Remember, thetas are universal. It's better than x. It's better than n. It shows you that's supposed to be some angle. I just don't know what it is. Okay, moving on. Now, this is where life gets easy again, because you know that pi over 4 is just 45 degrees. Well, if you were like, I didn't actually know that. Well, you could have gone like this. And I told you 180 divided by 4 was going to come up a fair amount. So it's probably smart to memorize it. You can always cut things in half and say 90 divided by 2 then. You get how 180 divided by 4 is like 90 divided by 2, and then what's 90 divided by 2? 45. So this really is just tangent of 45. And if you can't do that with this triangle sitting in front of you, I have lost faith in mankind. Do tangent of 45, please. And write it right here. I'm not saying that you wouldn't make a dumb mistake, but you shouldn't be baffled by this at this point. Sine, cosine, tangent, those are all easy, but what the heck is secant? We just reviewed it earlier. Refuse to do secant. Do the sister function and flip it. Okay. So, tangent, TOA. You might be confused. Which one do I use? You'll get the same answer. It doesn't matter. On the 45, 45, 90, they're the same. So, TOA is opposite over adjacent. It's 1 over 1, which is 1. Who had 1 there? Raise your hand if you did. Okay, good. Secant, I don't do secant. I refuse to do secant. It's like there's a famous line from housekeepers is like, I don't do windows. It's true. A lot of people will clean your house, but they won't do the windows because it's such a pain in the butt. So they'll be like, I don't do windows. Well, anyway, I don't do secant. 1 over, and then secant, I'm going to choose to not do secant, but it's cosine, really. Why did I put the 1 over there? To remind me that I'm not just going to do cosine, I'm going to flip it. Do you remember putting 1 over something flips it? It's just a reminder, don't forget to flip it at the end. Because if all I do is do cosine, which is adjacent over hypotenuse, 1 over root 2, then I'm going to forget to flip it. Because I got to flip it. So what's the final answer? Root 2. You got to do 1 over this. And if you hadn't learned this yet, 1 over something makes it flip. So now the answer is that. You could say over 1, but then that's not simplified all the way. So final answer, root 2. All right, how about the sine one? Sine's opposite over hypotenuse, 1 over root 2. Now, with having me so many times today already clean this up by doing this, I get some of you might have done that. You don't have to, but if you did, I'd be like, ooh, that kid's pretty smart. It's not required. Did anybody do it? I thought somebody might. All right. It doesn't have to. This is a perfectly okay answer. But so is that. And they are equal. Okay. Pretty intense, isn't it? Can you imagine if I hadn't been teaching you this for 3 days already? How intense this would have been? All right. Now how about this? It's the same exact kind of question. It's just I'm not going to tell you what pi over 6 is. You got to figure it out. Triangle's already there. Take a second. Get me these 3 answers. I'll pause while you give that a try. Dice of Destiny. Who should I call on? If you don't know, it's okay. I'm not going to embarrass you, but I will walk you through it. The reason I don't just go to somebody else is if I always just go to somebody else when you say, I don't know, a lot of kids will just say, I don't know, every time I call on them. So it's worth trying because I'm going to make you walk through it with me anyways. Row 1, person 4. Ava, that's you. Sine of pi over 6. Which one of these is pi over 6?
30.
The 30. So they really said sine of 30. And then what is it? 1 over 2. Raise your hand if you had 1 over 2. Good. Cosecant. Peacefully refuse to do cosecant. And do something else and flip it. Row 6. Great, and that's you. Cosecant, no bueno. Replace it with which one? Do you remember? Sine. So do sine of it, but then flip it. So what would sine of it be?
1 over 2.
So then flip it.
2 over 1.
2 over 1. Final answer, 2 over 1. This would have been 1/2. Sine is a half. That's great, but that's not the answer. The answer is 2. All right. Tangent of pi over 6. It's like TOA. Row 1, person 2. TiVo, that's you. So TOA, opposite over adjacent, 1 over root 3, and there's probably somebody out there who did this. You don't have to, but you would add root 3 over square root of 9, which is 3. That or that. Okay, move on. Cosine of pi over 3. Okay, I feel like this is actually a little too easy. We've done these enough times that these are all the same thing we just did a second ago. Skipping that page. Go to this one, and this is important. I only like one question during homework today. Sorry, I kicked that thing. And it was about this. So let's talk about it. Draw me a triangle. Every single time you are stuck in this class, please draw a triangle. Like seriously, for this whole unit, it's always about a triangle. And then make it short and fat. Remember, I don't know how long the sides are, so make it short and fat. And put the angle down on the bottom. That's the key angle. For every time you're stuck, draw this and then go back and go, well, what sides do I know? Oh, it's sine, so I know opposite and hypotenuse. They told me the opposite was root 3 and the hypotenuse was 2. And then find the third side in the triangle. And hopefully you just have this one memorized. Opposite, hypotenuse, what's the other one got to be? 1. And as soon as I put a 1 there, I go do, 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 do. What's the one across from that? What's the angle across from that? 1 in your head you got to connect with on the 30, 60, 90 triangle. That's the 30. If you didn't know that, you got to put those together. The small side goes with across from the 30. So, we now figured it out. We wanted to know what theta was. And if this is 30, what's this got to be? 60. But both in degrees and radians. Well, you're smart enough to know that 60 can be converted to radians. It's pi over something. Got it memorized yet? Probably worth memorizing this. Pi over something. Pi over 3 is right. But let's say you're not as quick at memorizing as she is. She's got that memorized. Day 1 was about, can you convert the radians to pi and pi to radians? And I said the most important thing was to know that pi was 180. And look, I could do this thing and it will simplify down to pi over 3. So that'd be a way to get it too. So the answer was in degrees, it was 60. In radians, it was pi over 3. I would memorize this one. And I would memorize that 30 is pi over 6. Those two come up so often, just memorize them. You know, like there's certain things in life you should just memorize. If you have to go use your calculator to do 2 times 3, it's embarrassing. You should memorize it. 2 times 3 is 6. You gotta know that one. Well, this one comes up so much in trig. 30 is pi over 6, 60 is pi over 3. Just memorize them. You can always go backwards and go, well, is this 180 over 3? Yeah, 180 over 3 is 60. You can do it that way, but memorize that pi over 3 and pi over 6 are certain angles. Okay, enough about that. So what's the answer to the question server? They didn't know the angle. Now we do. It's either 60 or pi over 3. Okay. This one, I want you to draw this out. Remember, short, fat triangle? Try this. This is the last problem I'm doing with you. I know some of you are drifting. Stay with me. Last question. We can do this. Draw a triangle, short and fat, with an angle in there. I put the angle on the bottom. You'll be able to use your phones again in a minute. Just focus with me one more time. Draw your short, fat triangle yet? Did you put a theta in it? And I know you might be like, this I don't recognize these numbers, but you should know that cosine is adjacent and hypotenuse, so you know they told you the adjacent and the hypotenuse. Xavier, what was the adjacent? Yep, what was the hypotenuse? And then you might be like, I don't know this triangle. It's okay. You could figure out the last side by doing that square root thing. You can do this. So, square root of this squared, well, that's easy. 2 squared. What's that? 4. And is this the longest side? No, so I go minus. And then square root of 2 squared? It's not that hard. Square root of 2 times the square root of 2. Square root of 4, which is 2. So there, 4 minus 2. What is the square root of 4 minus 2? Well, it's the square root of 2. Do you recognize that this is the 45, 45, 90? Because those two sides are the same. Yeah, you get that? Because these two sides are the same, it's got to be the 45, 45, 90. You just figured out that that was 45 then. Does that make sense to you? These are equal. If those are equal, you must be in the 45, 45, 90. You can't be in the 30, 60, 90. All right. That was the difficult one that we had to get to. So keys to today, you draw triangles. You label them with the sides that you know. You figure out the third side. And sometimes your 45, 45, 90 doesn't look like 1, 1, root 2 because they messed with it and they divided everything by root 2. And then they rationalized it and times it by 2. All right, so moral of the story. Let's get to the homework. We're going to just do the evens today. And that cuts your life down to half as much. As long as you actually do the ones I tell you to do, you'll be fine in here. Turf. I see that, folks. Gotta put it back up at phone jail. It's distracting you. All right. So, Xavier, can you tell me what number 2 is on the homework? And what is tan of pi over 4? Well, that's the same as tan of, do you have it memorized, what pi over 4 is? It's like 30 or 60 or 45 or 90 or, you know what that one is? Anybody know what that one is? 45 is correct. They're really asking you tan of 45. All right, so tangent of 45. Well, I guess I could draw 45, 45, 90. That might help. Oh, it is. Yeah, I know this one. It's going to help a lot. TOA, opposite over adjacent. 1. Raise your hand if you already had one before I said it. Nobody? Okay. Do you get? I just drew a 45, 45, 90 because I needed tangent of 45. And TOA is opposite over adjacent, so it's 1 over 1. All right, let's do number 4 together. Dice of Destiny, who should read it to me? Row 5, person 3, Marth. I refuse to do secant. I'm not going to do it. But I will do the sister function to it. Do you remember what sister for secant is? Cosine. You got to memorize those. So I'm going to go figure out cosine of pi over 3. But then I'm going to flip it. I'm going to put 1 over the answer right away to remind myself that I got to flip whatever the answer is. Because I can go do cosine, but if I don't flip it, it'll mess me up. Next, I got to know what pi over 3 is. Memorize that one yet? 60. So let's figure out cosine of 60, and then we have to flip it. I know some of you are weak on your basics like this fraction over a fraction, and you thought, oh, that first 20 stuff, that's not important. We're not going to actually... Yes, the fraction over the fraction is in there because of this moment. You got to know how to handle a fraction over a fraction. So let's figure out cosine of 60. We'll put it right there, and then we have to do a fraction over a fraction. We'll flip it over. So cosine of 60, I'm drawing a 30, 60, 90 triangle. 30, 60, 90, 1 across from the 30. 2, square root of 3, cosine of that puppy, which one? Cosine of the 60. Here's the 60. Cosine of the 60 is adjacent over hypotenuse, which is 1 over 2, and then fraction over fraction. Do you know how to do a fraction? 1 over 1 over a fraction. You flip and multiply them. Final answer is 2. Who had a 2 before I wrote it? Awesome. Okay. Do you get this involved, me drawing a triangle on every problem? Do you get that there's certain triangles you got to memorize, like the 30, 60, 90, 45, 45, 90? That's what it really comes down to. Turf.
For that question, it's cosecant and then like.
Somebody said secant. I thought it was.
No. Oh.
Is it secant or is it cosecant?
It's secant.
Okay. If it's secant, then you use cosine. If it was cosecant, you would have used sine. All right, on to number 6.
So the final answer of the last one, would you not flip it to be secant?
It was 1/2. The answer was, cosine of 60 is a half.
Then you put it to 2.
And then I flipped it. So the answer was 2. So the answer to this was 2. So you might be like, why did you change it to 60? Well, because pi over 3 is 60. So then I drew the 30, 60, 90 triangle. Why did you do this flip thing? Because we didn't want cosine, we wanted secant. So when I changed to doing cosine, I got an answer of a half. Then I had to flip it. So then the final answer was actually 2. Yep.
Is it like required that you solve it using the opposite one, or can you just use like the secant one?
I would say this, what's required is that you show your work. So if you did it a different way and you were gonna do, I'm gonna memorize cho, sha, cow and go with, I know this one is hypotenuse over adjacent or whatever. Then I would just ask you to write that in there and stick in your numbers. So bottom line, you have to show your work. See, if kids have just an answer on their test, it is even possible you could do that all in your head. But it's also possible you just copy the kid next to you. And it'd be almost impossible to copy the work and the answer. That's why we require the work. Okay, so show your work. You can do it whatever way you want. On to number 6. I'm not going to finish all of them here, but Ethan T., would you read me number 6?
Cosecant over pi over 4.
Pi over 4. Right away, I'm going to change pi over 4 to 45 because I just have that memorized. I would do that if I were you. And then I'm going to go, but I don't really like cosecant. I'm going to peacefully refuse to do cosecant. And instead, which one goes with that? Sine. But do you get it's not the same as sine? That's why I put this 1 over my answer. That reminds me to flip my answer later. So sine of 45, I'm ready to actually do one of these dudes. 1 root 2. So many little things to memorize. That's why I said flashcards might be smart to like have a flashcard for that. All right, so then sine of that is opposite over hypotenuse, so it's 1 over root 2. Here's my answer, 1 over root 2. And then this reminds me, hey, don't forget to flip it. So final answer, root 2. Who had root 2 before I even said it? Cool, we're getting better. All right, keep working on those. There's an answer key. If the answer key is ever not posted, and you're like noticing that, send me a 2-second, Schoology message. Answer key, literally, just that. Answer key, and I will go, oh crap, I forgot to post the answer key, and I'll go post it. All right, if you have questions, please come on, bring them up. That's all I got for the lesson for today.